Hi everyone, today I want to talk about shell operator. So the idea here is we want to design a real-time pod monitoring solution. And we want to use open source tools available and get it done. So let's briefly start by going through the goal or an objective, what we want to do. We want to be able to monitor Kubernetes pod lifecycle events. So whether a pod is created or deleted, we want to know about it in real time and send a notification to Slack. In order to send the notification and detect the pod lifecycle events, we are going to utilize shell operator and its event handling. We are also going to use Crossplane and Terraform and other tools, which I will talk about briefly, but they are really an adjacent tools that comprise the bigger picture. We are focusing here specifically on shell operator. So let's talk a little bit about shell operator. What is it? Kubernetes consists of really loops. Control plane consists of various loops and controllers that observe pieces of Kubernetes infrastructure, whether it's pods, deployments, secrets, or various CRDs, and react on predefined set of events, whether something is created, whether something is updated or deleted. And that's how Kubernetes API and controllers work in concert to make sure that we can benefit from Kubernetes as a system, from its extensibility and its primitives. So if you think about controllers as being a key component that makes Kubernetes what it is, like makes it tick, shell operator is a very unique project. It's like this type of project that really is a kind of a cornerstone project or a building block rather. So it's not necessarily an end product that you want to expose to end users. It's rather a powerful tool that you can use to build part of your platform on. So shell operator democratizes creating operators, makes it easier, makes it more accessible. Typically, if you want to create a Kubernetes operator, you would normally do this in Go. There are various frameworks that help you create operators like Operator SDK or others. It involves coding, testing, all that stuff. This is quite a few moving pieces. You need to know what you're doing, and it's not that simple. It's not that hard either, but it's not something everybody could do. But if you are a sysadmin, or if you just administer Kubernetes clusters, you're used to maybe Bash scripts, maybe Python, maybe Perl, and you want to use your skills to hook up to the rich ecosystem of Kubernetes resource model. So that's what shell operator does in a nutshell. At one hand, it observes the events that Kubernetes generates, and on the other hand, enables you to hook various scripts. It can be shell scripts, can be Python, can be other binaries, and do something in response to the events, which is literally the operator pattern or other controller pattern. So you can read more about the shell operator. They have a quite nice documentation. I will leave links in video description. But that's just enough for the short introduction, why we have chosen shell operator for this example and why I want to show you how it works. So in a nutshell, you can use shell operator for creating custom controllers really quickly and reacting to various Kubernetes events. We are also using Crossplane. It's a little bit behind the scenes. I have quite a few videos about Crossplane and blogs. You can look them up. But it's essentially, at one hand, it's an infrastructure as code tool, very similar to Terraform. It uses Terraform under the hood, or Terraform SDK rather, and it just can create and manage infrastructure in various clouds. What is different from Terraform is that it extends Kubernetes with custom resources, and provides a consistent API that you can tweak and manage. At the end of the day, it's really a custom control plane. I don't want to get too deep into cross-plane. You can search various YouTube videos or blogs to read about. All right, the next tool we have is Terraform. I guess if you're watching this video, probably familiar with it, but it's again declarative infrastructure provisioning, infrastructure as code, also supports multiple providers, and in my case, I use Terraform to create a kind cluster. By the way, the link to repository with all the source code, all the files will be in the video description, so you can try to recreate it yourself. And finally, we are using kind Kubernetes in Docker for deploying a local Kubernetes cluster to make it quick and easy. All right, so what I do typically to set up my environment, I'm using something called Justfile. I have a video about it. The link will be above. You can click on it and learn what Justfile is, but this is essentially a command runner. It's very similar to Makefile, but focuses on running commands. So let's show what we have in our Justfile. So you can see Justfile has various recipes, similarly like Makefile, and we would typically run this setup recipe here, and this setup recipe would go ahead, create a kind cluster, set up crossplane, create various crossplane providers. Nothing really magical here, just a few bash scripts wrapped in Justfile recipes. So I already did it. We already have a kind cluster with crossplane running, all the providers configured, and we got everything set up for the demo. All right, so going back to shell operator can hook to various Kubernetes events and execute scripts based on those events. So let's look at one script that we are going to use in order to send a Slack notification when pod is created. So you can see this is a regular bash script, nothing crazy here. We have some variables capturing a secret which contains my Slack notification URL. But what is special here is this block. So when shell operator runs inside the cluster as a pod, and you have those hook files baked into a Docker image in a hook folder, and shell operator would go through all those files and essentially trigger them. So register them as hooks, and anytime the event happens that is corresponding to each hook, we are going to execute it. So first, shell operator executes the code with a config flag. So you can see here we have this config, --config. When the first time shell operator executes a hook script, it will simply register this config. It's a special object for shell operator that says, in this case, we are going to react on Kubernetes resources, and we are going to observe pods, and we are going to check the event edit. We have three types of events: edit, deleted, and update. So that's the first time, and then this hook is registered. So once this hook is registered and we create a pod, then second time shell operator will actually trigger a full code here. So let's make this a little bit bigger, and you can see here this is a normal script. So if you've worked with Kubernetes and used bash or some a little bit more complicated kubectl commands, you probably know what's happening. So here we are retrieving a webhook URL secret. We are checking whether the variable is empty. And right here in this loop, we are actually assigning various values from something which is called a binding context path. Binding context path is a special file generated by shell operator based on this configuration, that would contain all the values when new pod is created. You can look up in the documentation how it looks, but essentially it's a JSON or YAML file with all those values. So in this case, we check whether this binding context path exists, how many entries it has, and we use JQ to pull out of this binding context path, which is a file, various values. So we put pod name, namespace, timestamp, and image. And you notice those values are all coming from the pod spec. So we are essentially referring to a pod spec, which there might be more than one pod. We might have created multiple pods and registered multiple events for those. But if you look here, once this is done, once we've captured everything, we are actually creating a CRD. We are creating a custom resource in this case, which is part of the CRD from Crossplane providers. So I don't want to go too deep into this, but essentially Crossplane has a concept of providers very similar to Terraform, and this provider is an HTTP provider. So it essentially enables you to create an HTTP calls in the form of Kubernetes API. So it's called disposable request. It will have a name. It will have a webhook URL that is retrieved from a secret, and then it uses settings on the post REST call with things like channel, username, and the content of the text. So you can imagine what's going to happen when we create it. We could call directly Slack URL, but I chose to do this like that because it's more flexible. I can be much more flexible with this type of flow, where I can actually create a Kubernetes object and then let Kubernetes reconcile it and essentially at the end of the day trigger an HTTP. I realize it's a lot to take in, especially if you're not familiar with Crossplane, so I ask you to suspend disbelief until we get to the demo part, and you will see how it works. All right, let's go back to the slides. So this is the script that is going to react when pod is created. We have a very similar script that is going to react when pod is deleted. The only real difference is this deleted hook event and also a slightly different text in the disposable request. Otherwise, it could have been one script. We could have two deleted and added events, and then just within the script make a distinction, but I chose to have two scripts just for the demo. All right, so one more time, we are looking here at the disposable request in its more like a canonical form, how it could look like with the body specific to sending a Slack request. So we have the scripts. We have decided what do we want to do. We have baked everything in. So how do we actually create something on our cluster that will trigger those scripts? So the way it's done, we are actually building a Docker file, and we are creating a Docker file where we are basing off of the Flant shell operator latest. This Docker image contains various tools like JQ, Kubectl, and so on that are pre-configured, and of course it creates a shell. It contains a shell operator binary that will look at the hook directory, and all the files that are in the hook directory, which were the two files we looked at previously, are going to be registered as hooks and then appropriately triggered. Once we have this Docker file, we can typically build it and push it to a repository. There's nothing crazy here. In this case, I already pushed it to my Docker repository. You obviously have to remember to be logged in. This can be private repository, so that's nothing shell operator specific here. So in order for shell operator to work, it is a pod, right? So it will trigger Kubectl, and it will use various commands. So it needs a service account with access to various Kubernetes resources. So in this case, we have created a typical Kubernetes RBAC file we have created a service account, and we have created a cluster role. In this case, we have added pods, namespaces, secrets, as well as the disposable request, which is the custom resource definition we've seen earlier. So shell operator needs these permissions in order to be able to interact with Kubernetes resources we wanted to interact with, which is a sane security measure. So we've applied those as well, and we also have a shell operator on the cluster. So how does shell operator look like? So shell operator is deployed as pod, really quickly and simple, nothing crazy here. It has a name of shell operator, namespace default, and it's actually the container that is going to run in the pod is taken from my image, which we've seen earlier. And the service account name is also the one that we configured with the permissions and RBAC. So we can deploy this pod, and we can deploy the permissions into the cluster. Once it's there, we can start interacting with it. So I've already did it. This just recipe would create a shell operator with RBACs. Already it's on the cluster. So let's see if we can actually make it work. So what you see here on the right hand side, in Firefox, we have a Slack with an app notify channel that is configured in my cluster so that whenever a new pod is created, shell operator will use our scripts and trigger the message. So let's see how it works. I tested it a few times, but this is the first time on this cluster, so fingers crossed. We want to create a simple test pod Nginx with the default latest Nginx image, and if everything goes well, when we trigger this code, I'm using Ctrl-E in the slides tool to do this, then we should see the notification. Let's check it out. It says that the pod is created, and indeed we have a webhook bot notification that the test pod Nginx namespace default is a timestamp, and this is an image that is being used for the pod. So everything works well for the creation script. Let's see if we are lucky with the delete. So let's delete the same pod. The pod is deleted, and we also have the pod has been deleted notification. So this is obviously a naive example. You could literally put here anything. Shell operator repository has quite a few examples. Some of them are pretty complicated, some of them are easier, but I really encourage you to check it out. So that's essentially it. Let's see what we have built. So what we've done so far, we used shell operator to simplify building custom operators. We literally had to create a Docker file, 2 shell scripts, and that's it. And the shell operator pod manifest with some RBAC. So this is the process of creating. And you know, I showed you how to do it with shell scripts, but it could be also Python script, it could be Perl, it could be a binary like Go or something else. Shell operator will run any binary within this folder. So we are very flexible as it how do we want to do this. So you could obviously imagine having it in Python, adding tests, making it a little bit more robust. Obviously scripts are a bit finicky for this, but for something simple, it's extremely useful, and you can essentially automate your Kubernetes with all kinds of useful things. You can, for example, copy secrets from one namespace to the other. You can automatically add RBAC permissions. There's all kinds of use cases here. As I mentioned earlier, it's more of a building block tool rather than and kind of end goal for users. So if you are focused on a DevOps area or a platform engineering or somewhere like that, that would be something I would definitely give it a try and check it out. All right, let's wrap it up. So we use Crossplane and Terraform to provide infrastructure management. I deliberately chose to mix those tools. I didn't have to. We could just stick to a shell operator example, but to show you how it can kind of work together in a single ecosystem where various tools are combined together, which it's more closer to reality how real projects work. We use kind for local development. This would obviously work with any cluster. And we've achieved our goal of having a real-time notifications on Slack. We enhance our cluster observability. We could maybe add something like if there's a pod with special label or something deleted that is important. I think you can imagine various more realistic use cases here. All right, so that's it. I hope you enjoyed the video. Let me know in the comment section below if you would like me to expand on anything. Otherwise, thanks for watching and see you in the next video.